Yeah. Right now, we're going to get started with our next speakers. These people are from Arizona State University, and they're going to be talking about a block-based database querying app. So yeah, take a couple seconds for me to make them co-host so they can share their screen and everything, but then they can introduce themselves.
So thank you very much, everybody, for joining this session. We're very excited to talk about DBSnap and to show you how the system works. This is a block-based database querying app. My name is Yasin Silva, and I'm very happy to be here presenting this with my collaborators, Humberto, Razente, Michael Barden, and Heather Flynn. Michael and Heather are two of our amazing research assistants, and this project is being developed at Arizona State University. So what is DBSnap? DBSnap is a web-based application to build database queries by connecting and moving blocks. It supports the relational algebra language in theory, but because of the commonalities between relational algebra and SQL, which is an industry standard for querying languages, especially in relational databases, it actually, DBSnap supports a large subset of the SQL language too. So DBSnap supports constructing very intuitive queries. And for this, we have developed our own types of blocks. And you will see that the main structure is basically building these query trees. And we are using query trees instead of the more traditional shapes of code in Snap, because I teach database languages and database systems at ASU. And educators like myself, we have for a long time known that students can very quickly visualize the idea of a query if they see the query execution tree. So query trees are very intuitive ways of building a query, and we are using that representation to support and to represent queries in DBSnap. The system is also built to be highly dynamic, and that means that as the user, as the student builds the query, the system actually shows intermediate stages of the query that are being constructed. So as soon as somebody moves a new block or connects a block with the existing query, then the new result of the query will appear immediately without the need of executing the query itself. Also, the student is able to inspect the internal result of any intermediate node in the query tree by just clicking on that node, and that intermediate result will appear immediately on the interface too. So these are some of the most important blocks that we have in Snap. As you can see, they look very different than traditional blocks in Snap. We have two large types of blocks. We have the dataset blocks, then we have our operator blocks. The dataset blocks are like what you see here at the top, which is we have a couple of examples there, table students that contains a list of students. And you can think of each of these tables as being a grid of data where basically we have every record in a line or in a row, and we have columns that represent multiple attributes for each of these data sets. For example, for the table of students, we may have attributes like student ID and student name, student age, and so on. Here on the right-hand side, we have course student, and these are very common tables that map information between multiple tables. In this case, we have the connection between students and the courses that these students are taking. And basically, this table contains the IDs of students and also the ID of the courses for the courses that these students are taking, right? On the bottom part, we have the operators. And I just wanted to comment that we're looking for some time about what would be the right representation for the operators and in general for the blocks we were using in DBSnap. And then at that time, my two sons were playing with these toys. This is a type of a Lego toy where you have to build these type of structures here, as you can see in the top right. And then basically the skeleton part of that structure, you build it using these type of blocks. And when I saw that, I thought, maybe we could use something like that. So anyways, that's how we got inspiration of the blocks. Here, as you can see, we have two types of blocks. The select block basically has one input and then an area for you to write condition. I will explain that in a minute. And on the right-hand side, you see other types of operators, which actually use two inputs. And we will see in just a little bit how these two work. right? So let me introduce some of the core operators. First is the selection operator. We have here on the top right an example of a query. And basically what the selection operator does is, think about the table. The table is, again, a grid of rows and columns. And what the select operator does is basically it selects a subset of the rows. So in this case, out of the entire list of students, we want to identify the students who are senior. So we select, providing the condition here that the level should be equal to senior. And basically we're selecting a subset of the records, or a subset of the rows. And here on the bottom part, we have the projection, which is very similar operator. And what the projection does is it selects, rather than a subset of the rows, it selects a subset of the columns. So in this case, for instance, we have that out of the table students, we are selecting, or we are projecting, more specifically, the attributes student ID and last name. Okay. So here we have two more of the operators, and these are a little more advanced operators. We support a range of join operators, and basically what the join operators are the main operators to combine multiple data sets. There are multiple of these operators available in DBSnap, and probably the most useful and also the most intuitive is the natural join. And the natural join basically combines two data sets. In this case, we're combining the table students and the table course students. And let me just minimize that. And in this case, the way natural join works is that it's going to link the records. It's going to combine the records where the records that contain the same value for any common attribute between these two records is the same, right? In this specific case, table students and table course students share one attribute, and that attribute is student ID or SID. And so the condition will be that the operator will combine these two tables, applying that condition, that the value in student ID on a record from students should match the value of a student ID coming from a record in course student, right? And so basically what that query is doing is identifying the list of students and the courses they are taking. And finally, here in the bottom part, we have an aggregation query. Aggregation is a very useful operator. And what it does is basically what you are expecting it to do. So we have the table of students here, and this aggregation operator is going to group the data. And in order to compute this operator, we need to provide two items of information. We need to first tell the operator how we want the data to be grouped, right? And that is through the group by statement here. And in this case, we are specifying that we want to group the table of students, or we want to group the entire set of students by level. So that means that we want all the senior students to be a single group, all the junior students to be another group, and so on. And then in the bottom part, we provide the second piece of information, which is what do you want to generate? What type of aggregation do you want to compute for each group? And in this case, we want to compute the number of students in every group. So we express that by using this aggregation operator count, and then we specified what we want to count. In this case, we want to count the number of SIDs, or the number of student IDs, which basically is the number of students for every level. And so this query will compute the number of students for each of the levels, right? So moving forward, Humberto will show a little more advanced queries, and then we'll actually show you the interface of DBSnap, and then our two students will will demo actually some of these operations using the actual DBSnap system, right? Go ahead, Humberto.
Thanks. Let's see our first example, full example. The question is to list the professors with last name Kelly in the courses they are teaching. The notation to answer this query is, in relational algebra, is a selection, the small sigma, where last name equals Kelly, and from professors join course professors. The DBSnap, we drag and drop the data sets, and as they have the same names for primary and foreign keys, we can use the natural join operator. Then we drop the select operator, and we set the condition last name equals Kelly. Next slide, please. In our second example, let's compute the number of students of each level registered in each course, considering only junior and senior students. The user can start from any operator. Let's start bottom up. We drop the data sets and the natural join operators. To compute the count aggregate, let's drop a group operator and type the group by list and the aggregation function. Then let's filter the information to retrieve only junior and senior student levels with the select operator. Here we have the opportunity to discuss that an optimization can be done by placing the selection between the table students and the join, for example, instead of placing it on top of the group by. So we could do that, this analysis of the students. Next slide, please. This is the interface of the DBSnap. In one, it's where all our operator blocks are available. In two, presents the available data sets. And three is the query area where the user interacts most. Four presents the relational algebra panel. Five is a quick toolbar that allows to import data sets, load or save queries. 6 is the general result query panel where the users can see the results of the query. And 7 is the node result panel that allows the user to check the result of the operator that has the focus. Next slide, please. The DBSnap architecture is structured in 4 layers. Several of these layers were adapted from the original Snap. The top layer implements an HTML page, and the other layers are JavaScript libraries, where GUI implements general properties of the system. DBBlocks implements the operators and dataset connections, and Morphic is a basic library. You may find more information about the architecture in our previous papers about the system that are listed. Next slide. We have also compared the DBSnap with other educational tools aimed at relational algebra based on their availability, if they're open source, if they run as web or desktop application, if they support views. Well, the DBSnap presents all these features together. And next slide. Thanks. DBSnap is a live open source project. We are implementing new features that will be available soon. You can try the system online or download the source to run your own. And now Heather and Michael will show this system usage. Thanks.
All right. Thank you, Humberto. Let me stop sharing here. So Heather, you can take it from here.
Yes. Okay, hi everybody. I'm going to be showing several basic queries. So here's the DBSnap interface. In the bottom left over here, we can see the various data sets that we have. And above that are the operators. On the right-hand side, we have the query result and the intermediate node result, which I will explain more in detail as I'm building the queries. So let's just start by bringing over a data set of students. So there are 100 students and there are 5 attributes in this table, which are the student ID, the first name, the last name, the level, and the age. So if I wanted to choose from this group of students, students who are seniors, I can bring over the select operator and connect it with the data set. And then I can type in level equals senior. And as you can see now, for the level attribute, it's all senior. So all of it's only displaying now a subset of students who are all seniors. So let's use this data set again. So the project, sometimes you don't want all of these attributes shown. So if, for example, we wanted to show only or list only students by their student ID or their last name, we can do that. And now there's only two attributes being displayed, which are the student ID as well as the last name, but it is still showing all 100 students. We can even combine operators. So for example, from this data set of students, if we wanted to choose students only by their first name, who, for example, could be Nancy, we can select that by typing in first name equals Nancy. And now we have two students by the name of Nancy. And again, if we wanted to further specify and list these two students only by their student ID, their first name and their last name, we can drop a project right on top of the select and then specify first name, student ID, first name, and last name. And one of the great features of DBSnap is you can see each intermediate node result. So if we start down here, this is the original data set. So this is all 100 students listing all of their attributes. And if we go up to the select node, we can see that intermediate step where we have the two students, but we still have all 5 attributes. If we go up again, now we get the final query result, which is the two students by the first name of Nancy, displaying only their student ID, their first name, and their last name. So this allows the students or the user to really see what's happening at each level of the query. So often you want to combine data sets. So we'll combine these two data sets using the students data set that we've been using the whole time, as well as the course data set. So the course data set has only 2 attributes, which is the course ID and the student ID. If we go back to the students data set, we can see that there's also a student ID attribute. This is a common attribute that we can use to connect via natural join operator. So if we connect those two, now if we look at the query result, if we scroll down, there's an additional attribute, which is the course ID. So now we have a list of all of the students from the student data set with the course that they're taking. So now I'm going to hand over to Michael. I'm going to stop sharing my screen so he can share. And Michael's going to show some additional queries.
Okay, thank you, Heather. So I'm going to do a couple natural join examples here. This one you should have seen earlier on in the presentation. So let's grab a natural join and professors and course professors. So again, professors just has the PID, professor ID, and their first name and last name. And course professors has the CID or the course ID and the professor ID attached to the course that they are teaching. And if we combine that with the natural join, we see that's compiled into one row. So PID and CID are combined into just one row. And if we grab a select block, attach that to the natural join, type last name equal Kelly, we just get professors with the last name Kelly and the courses that they are teaching. So let's do another one here. Go to the natural join. And this time we'll grab students and course students. So with students, again, you just have the SID or the student ID, the first name, last name, level, and age. And with course students, similar to course professor, you have the CID, the course ID, and the student ID. And when we combine that with a natural join, again, it's combined into one row, all that data between the two data sets. Again, when we combine with a select block, and this time we type level equals senior, we just get the senior students and all the courses that they are enrolled in. And it's worth noting that the attribute or the value in quotes has to be case sensitive. So it has to match the case in the data set. So if I were to go just lowercase senior, nothing's going to pop up because it doesn't match the case in the data set. So just be careful for that if you're doing your own queries. So it has to match the case exactly. So let's do a couple of group by examples. Grab a group by block here. So we'll grab the students data set. Let's say we want to compute the number of students per level. So number of freshmen, sophomores, juniors, and seniors. So we're going to group by level. And for our aggregation function, we're going to count the number of SIDs, which will count the number of students per level. And here you can see we have 27 freshmen, 27 juniors, 23 seniors, and 23 sophomores. Let's do one last example here. This time we'll grab course students. Now let's say we want to find the number of students enrolled in each course. So again, with course students, you have the CID, or just the course ID, and the SID, the student ID. And we can see here, for example, ABH 494, we have 6 SIDs or students in ABH 494. So if we go to the group by block and group by SID or student ID, and we count the number of SIDs or students, actually, sorry, that should be CID, group by course, group by CID. We count the number of SIDs in each course, we should get the number of students enrolled in each course. So like I said, for ABH 494, we have 6 students enrolled, and for the others, you can see the amount enrolled in each course. So that wraps it up for us for the presentation. There's a lot more we could show you. We get a lot more complicated with these queries, but we encourage you to build your own. You can visit the link up here and show in the presentation and create your own. Other than that, if anybody has any questions, feel free to shoot them now.
There is a question in the chat if you guys want to check that out.
Oh, yes. So there is a question about about Jordi, about how do you connect DBSnap with a database? That's a great question, Jordi. So basically, the way right now, and obviously more features will be added as we move forward, but the way we support databases is we have a built-in database system. That's the traditional university database with professors, students, and courses. And a handful of other tables, but there is also the capability of uploading data sets. And in fact, we have in the project website documentation about how you can upload your own data sets and even a sample data set that you can upload. So it's customizable in the sense that you can upload your own data sets. And for example, if anybody here in the audience is teaching any database courses, most of the textbooks in database systems or for data analytics, they usually share their data sets. And so you can download those and basically use an comma separated value format and then upload that to DBSnap. So you can create your custom tables.
Okay, thank you.
Mm-hmm. Then just in the meantime, you're welcome to share any questions in the chat area. But since we have a few minutes, let me just mention that the features that we presented for DBSnap are just a subset of the features that it supports. It supports many other, obviously, operators, types of different types of joins, renaming operators, more complicated ways of selecting The grouping operator, actually, the examples that we show you were using the traditional count operator or count aggregation function that just counts the data. DBSnap supports several other aggregation functions like min, max, average, and things like that. DBSnap also as a tool supports several other features. Like, for example, it supports the concept of views. Views are basically a quick representation of a query. If there is a query that you use it very frequently, you can just create a view for that query. And so later on, instead of rebuilding that entire query, you can just use the view as a data set, right? And so you can build your queries using as inputs the direct data sets, but also views, right? There is also the capability of saving queries, uploading queries. And in one of our recent papers, we built a slightly different system that's called DBSnap Blocks. And then in that system, we actually have implemented the capability of storing the answer, the result of a query, a DBSnap query, as a traditional snap list. And so after you have connected or generated your data, now you have the list. And now you can build, you can still use all the traditional snap blocks to work with that dynamic list. And this is a very different type of a list because it's dynamically connected with a query, meaning that if the data changes or if the query changes, then the list will automatically regenerate, and then it will always show the correct result of the query, right? So there is another question here. What is the link to DBSnap that has been shared in the chat box? Thanks, Michael. And a quick way of finding it, finding DBSnap is just by writing DBSnap in Google. It's usually the first link that appears. There is also a quick video of using DBSnap that we have added in the project, in the SnapCon website for our presentation. There is a question from Leonardo that says, where can we find some of the shared data sets? Are there lesson plans designed for DBSnap in a course? Great question, Leonardo. Thank you. And we have received requests from different colleagues to provide some information. So we have built some tutorials that are available in the DBSnap project. As I mentioned before, there is an introductory video there. There is a quick tutorial of how you can create queries, the different shapes of queries, a description of the built-in data set. And then there is also some tutorials like to upload your own data set. As we move forward, we will continue adding on that. I believe there is right now one sample data set that you can incorporate in addition to the built-in one. But as we move forward, we will try to incorporate additional data sets. I think that will be a nice addition to DBSnap. And also we are, in the designing stages, thinking about how this could be materialized in terms of adding a more direct link with maybe some data sets that might be available online. So maybe providing the capability of dynamically linking with some of those data sets might be also a future addition to DBSnap. All right. Are there any other questions? No? All right. Well, thank you everybody for joining the session. As I said before, and I think my collaborators mentioned this, we are continuously working on improving the system. We have been working a lot on the back end, trying to improve things, provide additional features in DBSnap. A lot of that is really driven by requests from people like you. So if you are using DBSnap or if you are interested in using DBSnap, please contact us. You find all the emails and the contact information of the project in the project website. Again, just Google DBSnap and you will get there using Google. Thank you, everyone. And thanks again to my collaborators.